All right, good morning. First thing I wanted to do was address a question. It's a question I've talked about before on this stream, but I wanted to cover it again, maybe even from a different angle. What happens when you have a large number of sides for your regular figure and you're trying to find the area of that thing? Let's do that thing over there. Let's get my calculator up and running. Because you're going to need a calculator for this one. There's no way to not have a calculator for this one. So as you're going through, there are going to be certain shapes where you can easily figure out the area and certain shapes where you have to use trigonometry. Three-sided figures, four-sided figures, and six-sided figures all have somewhat, you might say, of a shortcut where you can divide it into certain types of triangles, and the triangles are all nice, so to speak. But anything else, if it is not a three-sided figure, a four-sided figure, or a six-sided figure, you're going to have to do trigonometry in order to get everything you need from this. Now, the strategy is still going to be the same as with those. You're going to divide your figure up into triangles like this. Go from each corner to the center of the figure. Each of these lines that I've drawn here in the middle is called a radius. And what we need to be able to do is we need to be able to figure out the radius of this figure, because there's a formula that we know for triangles. One half AB sine x, where A is this guy over here, B is this guy over here, and X is the angle in degrees in the middle. So as you're going through and doing this, what's going to end up happening is you're going to need to figure out what this side is. How do we do that? Well, basically, what we're going to need to do is just like the easier ones, we're going to need to have this angle here in the middle. Knowing these central spoke angles of the figure is going to help us regardless. When it was the 30, 45, and 60 degree angles up in here, we knew that we could use those special right triangles. But here, we're only doing this because we want this angle right here. Once we know what X is in here, in this case, you know, the whole way around is 360, and there's 5 of them. 360 divided by 5 ends up being 72. So we already have our degree measure. This is X. So that's step 1 done. All we need to do is figure out what A and B are, and luckily A and B are the same thing, so we don't actually have to do all that much in terms of work. Now, from here, basically, it's going to depend on the information we're given. We could be given A and B straight away. We could be told, hey, the radius of your figure is 5 inches. Well, hey, now we know what A is. Now we know what B is. We can find the area of this here triangle. Just plug in the numbers that we've already found, and we get our answer. We're going to need a calculator for this because sine of 72 isn't a particularly nice looking number. 1/2 times 5 times 5 times sine of 72. And again, before I even go any further, let's double check, make sure that I am in degrees. See here, it says degrees. I know I'm good. And I've typed this into my calculator, and I have the area of one of these triangles. 11.88820645. Zero, 20645, sorry. 20645. I can only remember like 4 or 5 things at a time. And this is one triangle. So the thing of it is, I look and I see how many triangles I actually have. I've got a pentagon, so I've got 1, 2, 3, 4, 5 triangles. So I've got to, in order to get the whole thing, I've got to multiply by how many triangles there are. In this case, 5. So I'm going to take this guy, I'm going to multiply by 5 since there are 5 triangles, and I get 59.44103227. And then, so this is how I would go about finding any of these. First thing I have to do is find what the angle is. Well, I look at the number of sides, divide by how many sides there are, get my middle angle here. That's x. And then I know what the radius is because they told it to me, so I put those here. I find one triangle, and then I multiply by how many triangles there are. So where this gets more complicated is what happens if they tell you just any old thing. What if they say, all right, well, it's a 52 gon. Ooh, what's a 52 gon? Well, 52 gon. Okay, so gon, this, the word, the suffix just is the mathematical suffix to mean sides, or thing with that many sides. So if it's a 52 gon, it's a shape with 52 sides. Now that's a lot. I'm not going to draw a picture of that. I can't. I'm not going to. So what I'm going to do, though, is I'm going to do the exact same thing I did before. First, I need to find my angle, and I should maybe give all the rest of the information. So our radius is 10. So here's our given information. Everything else we have to figure out for ourselves. So I've got a 52 gon. Well, I'm going to do 360 divided by 52, and that's going to be kind of an ugly number. It's going to be around 7. but let's do it in the calculator to get something actual. Like I said, it's around 6.9. But now we do need to have the exact thing. So when I go through and I write out my this is my x. I'm gonna use that entire decimal. I could also just use the 360 over 52. Either way, in fact, this is probably less button pushes. So maybe I'll do this. I'll show you how that's done as well. But then the other thing, so that's x. And then the radius is both A and B. So let's now write it out. We've got 1/2 10 times 10 times the sine of and so when I put this into the calculator, again, 1/2 times 10 times 10 times the sine of in here. What I'll do is I'll show you how to write this out. You can just do 360 over 52 and see how it's all in parentheses here. That's how I know that what I've done is correct. And this 360 over 52, that's 6.9 something. So I go through, look what I got. This is my area of the one triangle, right? So one triangle something 6.02683 6.026834013. This is one triangle, but I don't want just one triangle. How many triangles do I want? I want 52 triangles, because that's the whole figure, all 52 triangles. So let's put that in the calculator, because again, I'm not going to do that by hand. That's monstrous. I'm not going to take this and try and tabulate that out by hand or in my head. There's 52 triangles, and so my final answer here is 313.3953687. So I've got 313.3953687. You know, whatever the units are. But so the whole point of this is we can go through and we can figure out, with or without a picture. Here's a picture. Here's a pentagon, 5 sides. And I can go through and I see what's going on. But when it gets to be larger number of sides, ain't nobody got time to draw a figure with 52 sides. Never mind good or badly drawn, but just like draw in general, nobody's going to do that. I'm not going to do that. You're not going to do that. Nobody's going to do that. So it's good to have a concept of what actually is going on visually in your brain, but then you can just write it down on the paper with your equations and stuff. You don't have to try and draw out a 52-sided figure. That's ludicrous, right? So that's all there is to this one. When you're given the radius. If you're not given the radius, it doesn't even matter what the picture is, but if you're not given the radius, if you're given a side length or the perimeter, first thing you want to do is figure out the side length. If they tell you They tell you a 24 gon with side length of 10 centimeters. Well, then you're going to have to, again, you're not going to draw a 24-sided figure, right? Nobody's going to do that. So what we need to do is we need to figure out the radius, because we weren't given the radius. We were given the length of the side. So what I want to do is I want to draw just the triangle down here. You see what I'm saying? I'm just going to draw this guy, this triangle. So let me not draw that. Let me draw a triangle. Here's my triangle. Imagine this is like the slice of cheese out of the bottom that we had before. So first things first, they tell us that this is 10 centimeters down here, the side length. What we want is we want these guys, right? We want A and B and X, just like we had before. So we can do this, right? Well, X is easy to find. All we have to do is, this is one of 24 slices, so let's do 360 divided by 24, which I believe is 15. Yeah, 15. So this is 15 degrees. So we have X. This is X. We are one step closer. All we need to do is find A and B. So let's do that. Let's find A, let's find B. And we do that with trigonometry. What do you mean? Well, so what we're going to do is we are going to take this triangle and we are going to slice it down the middle to create a right angle. Ooh, create a right angle down here. Just like this. We have sliced this triangle completely in half, which means that this piece is 5, this piece is 5. And it doesn't matter which side we're going to do because either one's the same. So let's I'm gonna draw the slice out here. Like this. Here's my right triangle that I stole from here. Well, I know that this piece is 5. That's a right angle. I know this is what I'm trying to find. Let's call it A so that we're consistent. Right? A. I'm trying to find A. I also know that this angle is cut in half. It was 15, so the angle here is 7.5. Now, looking at this, well, I'm using SOHCAHTOA. Here's the opposite side. This is the hypotenuse. So, SOHCAHTOA, I'm using sine. And then I'm going to cross multiply and divide. So I'm cross multiplied here, and I'm going to divide. This is your A and your B, right? So, depending on who you are, the type of person you want to be on this, please feel free to either, is this going to take all that I want with it? Or is it going to be, we're going to find out, aren't we? No, it doesn't matter. I can just deal with this. So once we've done all of this, let me maybe scooch this up all up a skosh. So once we've finished with all of this here, So this is our A. We're good with this. And our B, because they're the same. We can now find one triangle. And again, I'm just gonna, instead of calculating this out prior, just plugging everything in. How did I get this? That's A. How did I get this? A and B are the same, so that's B. How did I get the 15 in here? That's X, which is 15, which I calculated up here. So I'm going to throw this into the calculator to get one triangle. So let me bring out Captain Calculator right here. And again, look at how I do this. I'm going to parentheses 5 times divided by sine of 7.5 close parentheses, close parentheses. So I've got one close parentheses here, one close parentheses here. You have to have both, otherwise it's going to yell at you. Or even worse, give you the wrong answer. Times 5 divided by sine of 7.5, double close parentheses. Again, you got a close parentheses here. You got a close parentheses here. Times the sine of 15. Make sure to close parentheses there too. That is this triangle right here. 189.89385828. 189.89385828. 8938528. So that's one triangle. That's one of them. How many triangles do we have, though? How many triangles do we have? We've got 24 triangles, right? So when we find out what our final answer is, we just take that and I don't know why I put a dash there. 24 triangles is what we actually want. One triangle is that. 24 triangles, we're just going to multiply by 24. And this number represents the area of the whole thing. 4,557, 452,468. And this is the whole thing. Okay, a couple other things that I wanted to, and that's it. That's all there is to it. Cover maybe some people, the one person out there who's watching is having trouble with is things like systems of equations. Let's look at a system of equations. So here's a system of equations right here, and there's a couple ways to go about solving this thing. You could very easily get these into y-intercept form and actually physically put them in a calculator. You could also use, for example, you could use one of the couple system of equation solving methods. There's substitution and there's elimination. When you've got the two equations looking like this, you actually want to use elimination. Elimination is most useful here because they're already lined up like this. So what needs to happen in order to use elimination is we need to make sure that the number in front of the variable for one of the two variables you get to choose, either x or y, are the same number but opposite signs. Now if you look here, these are both the same sign, these are both opposite signs. So if it was me, I'm gonna try and eliminate y first because it's easier to do this way. Now that's a personal thing. That is purely me expressing my own personal preference here. If you don't agree with that, please feel free to do the other one. That's fine. But again, what we want to do is we want to get these two numbers to be the same. So we're going to multiply both equations by something to scale them up to make these the same. Now if you look at 3 and 2, their least common multiple is 6. 3 times 2 is 6, 2 times 3 is 6, right? So if I multiply the top equation by a number that'll make this 6, and I multiply the bottom equation by a number that'll make this 6, with this being a positive and this being a negative, I can then proceed to add the two equations together and get an answer. So let's do that. Well, 3 times what is 6? 2. 2 times what is 6? 3. So I'm going to scale the top equation up by a factor of 2. I'm going to scale the bottom equation up by a factor of 3. And I'm going to rewrite that out. So remember, when you multiply an equation, or you multiply multiple things, you got to make sure that you're multiplying everything. 2 times 2 is 4. Plus 3 times 2 is 6 equals 4 times 2 is 8. Let's do the other one now. Times 3 to everything. So I'm going to multiply the 3 here, here, here. Everything's got to get scaled up the same, right? 3 times 5 is 15 minus 3 times 2 is 6 equals 3 times negative 9 is negative 27. So now what I'm going to do is I'm going to actually physically take these two equations and I'm going to add them up. I'm going to add straight down, combining my like terms as I go, adding the x's. 15 and 14 makes 19. 6 and negative 6, we better have 0. That's the whole point of this, right? The whole purpose of doing this way is to make one of these cancel out. If you don't get one of your x or your y to be 0, you have done yourself dirty already. Because the whole point is to get rid of one of your variables. And then 8 and negative 27. Now some people are going to have trouble with this because you're adding a positive and a negative number, and well, what goes where? What do we do? 8 minus 27 is difficult. 27 minus 8 is 19. But we did it backwards, so change the sign. 8 minus 27 is negative 27 minus 8, 19. So there's 0y, this goes away, right? 0 of anything, you can ignore it now. You got 19x equals negative 19. And then we can solve this one-step equation by dividing both sides by 19 and canceling out the 19s. From here, let's rewrite everything. X equals, well, what's 19 divided by 19? That's 1. And then there's a negative sign. So x here is negative 1. Now, the solution to this involves you having an x value and a y value, because you want to know where in space do these two collide. We've got our x coordinate, we've got how far to the left or right it happens. We need our y coordinate, how far up and down it happens. So let's do that. We're going to take this negative 1 and we're going to plug it into one of these equations. It doesn't matter which. You should get the same answer either way. But I'm going to pick the one that has the smaller numbers on average. 2, 3, and 4. Much less intimidating than 5, negative 2, and negative 9, right? Make life easy on yourself. Don't try and be a hero when you don't have to be. So 2x. Well, 2x. What's x? X is negative 1. Plus 3y equals 4. So I'm taking this equation here, and I'm taking this number here and I'm plugging it in where x used to be. Because we know what x is now. We're substituting negative 1 in for x because we know x to be negative 1. So let's go through. Well, 2 and negative 1, that when we multiply those we get negative 2. Now I can add to both sides. I'm going to add 2 to the left, add 2 to the right. These cancel out and go away. Left with 3y equals 4 plus 2 is 6. And then I'm going to finish my problem by solving this one-step equation for y. I'm going to divide by 3. Well, 6 divided by 3 is just 2. So my final answer, it's important that we indicate our final answer. Use gray. Let's see, gray. So final answer we end up with x comma y. We always put x first and y second. Our numbers go in alphabetical order. Final answer here is negative 1 comma 2. That is to say, if we were to graph these lines, because that's what this represents, right? This equation with an x and a y value represents a straight line. If we were to graph this line and we were to graph this line, the place where they would touch is at the point negative 1, 2. Let's go through. Let's actually graph that. So we are going to graph these points. Now, I'm going to graph this one in green, and I'll graph this one in red. Have it be very Christmassy. Christmas in April, that's what I say. Okay, so let's start with the green one. I've got, so I don't know how you've been taught to do graphing of a line like this, if you have. If you have not, there's a couple easy ways. I can find the x-intercept by making y equal to 0. That's, because it's along the x-axis. So I can just say y is 0, then, well, 2x equals 4, so x equals 2, right? That's your x-intercept. And I can do the same thing with y. Make x equals 0. So this is 1 1/3. Well, that's going to be about here. And then I can also do the other one. Let's do that. So my x-intercept doing this same thing is going to be -1 4/5. And then my other one, I'm going to solve for y. Or to do -9 divided by -2, I'd get 4.5. And what you're going to see is that make my, now if this were actually, yeah, let's if this were my classroom, when I'm telling my students to do this, I tell them make the lines as long as possible. I even have a set of straight edges in my classroom so that they can do that much more easily. But here, luckily, I can keep my lines straight without too much trouble. And you're already seeing that it's going through the point that we showed before, -1, 2. But the key is it's got to go through. It's got to go through it through both. Notice here, that's where they line up, right? So our now, the one thing to be careful about with a method like this is a really good way to visually show what's going on, but it's a bad way to get good, accurate answers. I often tell people avoid whenever possible to doing it this way, especially if you're trying to do it by hand. If you've got a graphing utility like this, and you want to put it in slope-intercept form, be my guest, you can actually do it this way. -2/3 x plus 4/3 is that first one. Five halves x plus 9 halves for that 4.5. That's where that came from. And you can see that it actually comes out, and it'll come out the same way as what I did as it goes through the. If you're doing this on a graphing calculator, you can actually specifically calculate where they intersect. first identify which curve is going to be the first one. Here I picked the blue one. Second one I picked the red one. And then it wants you to guess about where you're talking about. And the reason they want you to do this, by the way, is because the way that the computer calculates this out is by by certain numerical methods, and they need a starting point in order to finish the problem. But look, if you can see, I don't know if you can see really, if it's too small, but it says intersection, -1, 2. And then that what we had over here? -1, 2. Isn't that what we had over here? -1, 2. So no matter how you do it, you're gonna get the answer correct as long as you're careful. Now, the other one I wanted to show you was with substitution method of solving a system of equations. And again, the substitution method is, I'm not going to say it's more versatile, but it's more versatile. The key is, regardless of what you're doing, you want to get it so that it is like this, where at least one of your equations is solved for a variable. It doesn't matter which variable, you can pick whichever variable you like. But if you are using substitution, you won't be able to do it unless one of the variables is solved for already like this. So here's what we do. Substitution. Just like it says in the name. We know that y, let me get a better color than that here. Let's go with blue. We know that y is the same thing as 2x minus 5. They are the same number. So in the other equation, here's y, right? There's y, there's y. Well, I'm going to take 2x minus 5 and turn y into that. What do you mean? 3x plus 4y equals -1. Well, here, what's y? 2x minus 5. So let's take 2x minus 5 and let's put it right there. See, what I've done is I said y and 2x minus 5, those are the same thing. So there we go. What am I going to do now? Well, I can distribute, right? Let's distribute. Four times 2 is 8. 4 times -5 is -20. And at this point, I can combine my like terms. (3x and 8x is 11x. And I can solve this two-step equation now, right? Now you're going to notice, some of you may be already seeing, oh no, this is not going to come out very nicely. That's okay. Don't worry. That is x. Already we're almost done, because look, we know what x is, we know y is solved for here, so let's take this equation let's plug x in to that equation. Y equals something. Y equals 2x minus 5. Now I'm going to take this 2, I'm going to multiply it to the fraction. 19 times 2 is 38. And now this minus 5, this is making this difficult to do. So what I'm going to do is I am going to turn this 5 into a fraction with a denominator 11. So I'm just going to multiply the top and the bottom by 11. And then I'm going to actually do my subtraction. And remember, taking a smaller number minus a bigger number is hard, but all we're doing is we're doing a normal subtraction, 55 minus 38, and then switching it, making it the opposite sign, right? So 55 minus 38, that's easier. That's 17, right? And always double check to see if you can simplify your fractions. Here you can't, and that's okay. Here's my answer. Let me scooch this up so I have some room to write my answer. Make it a little bit more smushy. But my final answer, xy, is 19 over 11, comma, negative 17 over 11. And that's my final answer. Alright, so for question 4, they want you to solve a proportion. So let's take a look. Here's our proportion, right? Good, I'm glad you finished the last 2 assignments. I will be updating grades on those, if not today, tomorrow, for sure. So if you take a look here, here's our original. Remember, step number 1 is to cross multiply, and you want to write it out. So we got 5 times the quantity x plus 4 equals the other one, 6 times 10. Now, when we do this, remember, you have to distribute. This first one, 5 times 1 is 5x. 5 times 4, plus sign in the middle. 5 times 4 is 20. 6 times 10, well, that's 60. And now I'm just going to, two-step equation, I'm going to go ahead and I'm going to subtract 20 from both sides. $60 minus 20 is 40. Now I'm down to a one-step equation where I'm going to divide. $40 divided by 5 is 8. Okay, so with this one, we're talking about finding the arc. What's going on with these, for number 9, they're asking about the arc length of this circle from here to, let's say, from here to here. Let's Draw it out. And let's say this is... So I want to find how big this red curve is, right? So the way to think about this is that we know how to find the whole circumference of the circle. We know that pi d is the circumference of the circle. This is 72 degrees, and we need to have a radius here. Let's call this radius 3 inches. So we got 3 inches for our radius. I want the diameter. So if the radius is 3, the diameter is twice as big. So my circumference, the whole thing, the whole distance around, is 6 pi. But we don't want the whole thing. We just want this piece. That's the whole point. We don't want this piece. We want just this. Not the whole thing, just this part. So what we're going to do with that is we're going to say, all right, well, I know I only want 72 degrees out of the whole 360, right? So I can do 72 degrees out of 360 times 6 pi. What fraction of 6 pi do we actually want? 72 out of 360. That's what we're doing. And then all that remains to do, all that remains to be done is to simplify this fraction. Now, me personally, when I do this, I would much rather just simplify the fraction in parts. What do I mean by that? I know I've got 72 and 6 on top, because, you know, that's a whole number that's in the numerator, and then the 360 on bottom. So I'm going to cancel out my factors. I'm going to say, all right, well, what does 72 and 360 have in common? Well, 72 actually. 72 times 5 is 360, right? So I can divide this piece by 72 and get 5. I can divide this piece by 72 and get 1. And look at what I have left. And there's pi as well, right? 1 times 6 on top is 6. 5 on bottom is 5. And don't forget your pi, because pi was there too. And that is how I would get my final, very final answer. And you could write it 6 over 5 pi. You could write it 6 pi over 5. Either one of these representations is good for your answer. They'll be marked correct, as long as they're exact, like these are. You might even be able to get away with 1.2 pi, but I wouldn't bother with that. I would just do 6 over 5 pi, or 6 pi over 5. My email is always open. You can always send me an email, and I will put those questions up first on the next stream. So please make sure, email me questions. Don't be silent. Communicate. I will see you on my next stream starting around 11:30. All right. Y'all have a great one.